Good afternoon, students. In previous videos, we have studied about the refraction and reflection. So in this video, we are going to study about the total internal reflection. So the basic principle of optical fiber is the total internal reflection. So very important 2-mark question. So with this principle only, inside the optical fiber, the light is transmitting. So it is very important. Students, we can recall what is reflection and refraction. So reflection means when a light emits from one medium and it gets strikes in another medium and it gets reflected. Correct? And what is refraction? The bending of light occurs when it travels from one medium to other medium. Okay, based on the refractive index. So now we can see the principle of total internal reflection. Okay. So first see the diagram. Here let us consider a ray of light passes from glass to air. That is from the denser medium glass to rarer medium air. Okay. Then what happens when a ray of light, when it strikes on the surface, the major part get refracted and a small portion get reflection. Okay. Reflected. We have studied earlier. So same thing here also happening when a light is travel from the denser medium to rarer medium, major part of the light get refracted and a small portion get reflected. Okay. And the next step in total internal reflection is we want to slightly increase the angle of incidence. When angle of incidence increases, what happens? The angle of refraction also increases. So now the angle of incidence increases, the angle of refraction is also increases. So you can see the second diagram. The angle of incidence increases, the angle of refraction ray, that is that yellow line is also increases. Okay. Now in the third step, at a certain angle of incidence, that is the critical angle. Okay, what do you mean by critical angle? Means when the refracted ray travel along the surface of the two medium. Okay, so now that yellow line is traveling along the surface of the two medium, that is the refracted ray is traveling along the surface of the two medium. Now what happened? The angle of refraction is equal to 90 degree. Okay, so when the angle of refraction is 90 degree, that angle is known as the critical angle. Okay, so when angle of refraction is 90 degree, the angle is known as the critical angle. Next step, further we are increasing the angle of incidence. What happened? The light bounces back to the same medium. According to the law of reflection, we have studied two laws. So it obeys one of the law, that is angle of incidence is equal to angle of reflection. Okay. So this is the basic principle of total internal reflection. And now there are two conditions in which the total internal reflection obeys. The two conditions are the ray of light must travel from the denser medium to rarer medium. And the second condition to be satisfied is the angle of incidence must be greater than the critical angle. Okay. And now see this diagram. Inside the optical fiber cable, the light is traveling in a zigzag manner. That it is according to the total internal reflection. The last step of total internal reflection, we have studied that the angle of incidence, when it is greater than the critical angle, it gets reflected back. So I hope you understand the principle of total internal reflection. So this is the principle in which the light travel inside the optical fiber cable. Okay, thank you.